most of the time I'm working SO50. I like that too, and it's the same frequency. SO50 is. SO50 though typically takes 267 hertz to get in. And once in a while, if you have to bring it up, actually activate the satellite at 74.4 hertz, I believe that activates that. Usually there's someone talking on there, and I've never had it. Somebody's already activated. Yeah, usually that's the case. Well, we'll start hearing something in about a minute.
You know what our grid is?
This is EL98 to this area. Yeah. We'll start listening out. This is probably a little premature. Usually I don't hear it until about a minute or so after, but sometimes we get it a little early. So we'll start turning around and listening a little bit here. I'm going to turn up the volume a little bit. 5 minutes. 5 minutes to go? I thought it was 23 after.
Steps on? Steps. At 18 after.
So you have 18 after?
Well,
you're right.
Can you go through your spiel about the Doppler shift and the higher uplink, and I mean, because I didn't get all that.
Oh, sure.
Time. And talk a little louder.
Okay, very good. I'm not much on TV normally. Okay. Well, dealing with the Doppler shift on the satellites. The satellite is traveling about 17,500 miles an hour. And so what you have to do is compensate for the Doppler shift. The Doppler shift basically is an effect where a wave is compressed due to the speed the object is traveling toward you, and then as it's going away, you have this decompression of the wave, lower frequency. So you'll get this frequency rise and then drop. Basically what you, not rise and drop, but a continuous drop actually. So you have to start a little bit higher in frequency than your center frequency. It transfers through the center frequency at about the midpoint of the pass, and then will go down each new frequency toward the end. So you have to track the frequency of the satellite as the pass is continuing on. What do we have to go through? About 3 minutes? Okay.
You got 3 minutes until it rises and maybe another one before it turns on.
Okay.
Do we know where which direction we're? Well, it's gonna.
Let me get that. Hold on.
It's gonna come up.
Hold on. Do it again.
Right now, if we were pointed at the satellite, it's still 8 degrees below the horizon at 147 degrees. So south's 180, 147 is going to be around here. It'll come up probably about 140. It's going to go in an arc, and it's going to get up to about 30 degrees above the horizon. Now, a good judge of 30 degrees, if you hold your fist out at arm's length, from the bottom to the top of your fist is roughly 10 degrees. So 1, 2, 3. It's going to get up to about that high, and then it'll go down. It should be about due north where it goes down. Now there's another view in this program where you can go in.
Kilo Alpha 1, Mike Delta Alpha Delta.
Kilo Alpha 1, Mike Delta Alpha, AA4KN at Orlando Navigation. Do you copy?
Kilo India 4, Whiskey, Quebec.
AA4KN at the Orlando Navigation.
WB Dyer. B9YIG.
B9YIG, AA4KN.
AA4KN, please.
Roger, this is Dave. I'm at the Orlando campstation giving a demo today.
Indiana.
I'm sorry, were you in Indiana?
Yes, sir. Down southwestern corner near Evansville.
Well, very good. Thanks for the contact. And everybody out here, I'm sure, is impressed by the satellite. So, appreciate that, Dave.
Alpha 1, Mike Delta. Kilo Alpha 1, Mike Delta Alpha. Kilo Alpha 1, Mike Delta Alpha.
Kilo Delta 1, Mike Delta Alpha.
Quebec Delta, November 2, Bravo X-ray. November, Kilo X-ray, Kilo Echo Mike. QSL Fox Nancy 0, Fox Nancy 20. Thanks for the contact.
Alpha Alpha 4 Kilo November.
Mike Delta. NC5N.
NZ5N, AA4KN.
Bravo 2, Hotel Sierra Hotel. Bravo 2, Hotel Sierra Hotel, Nancy Zulu 5 Nancy, Echo Lima 96. Okay, it's Fox November 02 here in Buffalo, New York, over. Kilo Bravo 2, Hotel Sierra Hotel, Nancy Zulu 5 Nancy.
That's Keith in Texas.
Is it Keith?
QSL, I am an Echo Mike 1-2. Whiskey Bravo 2, Sierra Yankee, Kilowatt, QSN, Fox November 13, over.
AA4KN, Orlando. Pretty nasty sound. Seems to be
That's ATV interference.
Bravo 2, Sierra Yankee, Kilowatt, Kilo Bravo 2, Hotel Sierra Hotel, Fox November 02.
AA4KN, Orlando. This is AA4KN, Orlando, Hampton.
AA4, W5I, C5, India uniform.
Whiskey by the India uniform, AA4KN. Go ahead. We're EL 98. Thanks, Keith. Echo Mike 1-2, 73, AA4KN.
Kilo Alpha 1, Kilowatt, Kilo Bravo 2, Hotel Sierra Hotel, Fox November 02. Kilo Bravo 2, Hotel Sierra Hotel, this is Nancy Zulu 5 Nancy, Echo Lima 96. Kilo Alpha 1, Mike Delta Alpha. Kilo Alpha 1, India Alpha X-ray. Kilo Bravo 2 Hotel Sierra Hotel. Here's Kilo Alpha 3 Hotel Sierra Whiskey. Kilo Alpha 3 Hotel Sierra Whiskey. Kilo Bravo 2 Hotel Sierra Hotel. Good afternoon, Fox November 02, over. Come again with New Square. I am Echo November 51.
Okay, let me trace back on. I'll show you. It's really very simple in this rig. This is a THD7A.
Let me get this from the start.
And this is a...
Hear my question again?
No, yes.
How are you adjusting for the Doppler shift on the handheld?
Okay, the Doppler shift on the THD7A is very simple to use or to adjust. Right now, this is where I left the passes on transmit. You hit the AB button here, turns on to the receive frequency because we're a dual band rig. You can go ahead and just press this down and step it. And if you watch, we're now on 436.795. You can step it up 5 kilohertz intervals. Normally on a pass you would start at about 436.810, and as the pass continues across, you'll go ahead and just adjust your receive only down. Your transmit frequency you let remain the same.
Always transmit on the same frequency?
Right. Transmit on the same frequency as conventionally used for the FM satellites.
Okay.
And so typically, like you were seeing here, probably about every 3 minutes or so, it's hard to tell, but maybe like today it was about every 3 minutes I had to adjust for Doppler, 3 to 4 minutes. And I just simply go down here. You got to remember on this rig too, that you switch up here, wherever the arrow appears is your transmitting frequency. So you go ahead and get it back up in that position. You're transmitting on 2 meters, listening simultaneously. There's your full duplex down on 436.8 in this case. When you want to adjust Doppler, you've got to hit the AB, move down to here, and then adjust your Doppler, and then move back up to transmit. And that's how you operate it, basically.
So you estimate 5 kilohertz every 3 minutes or so?
Roughly 3 to 4 minutes, and that can vary, but you know.
Now you can also store those in your memories.
Well, what
right.
I did on this, I haven't been successful yet, is have a bunch of different settings, all with the same transmit frequency,
yes,
and changing the receive frequency.
Exactly.
And that's what Google was just mentioning. That's what a lot of people do. Personally, I just do this and move my thumb. It's whatever fits your
style. And that's a 5 watt?
This is 5 watts.
Okay.
This you can also tune down to a medium power, probably about 2.5 watts, and down to half a watt, I believe. But it has 3 intervals.
Okay.
I just always keep mine on 5 watts.
All right. Now, the antenna I bought was an elk. This is an arrow?
This is an arrow antenna.
What do you think of the elk?
I really don't know. I haven't used an elk. In fact, it's the first time I've heard.
Periodic and
I know people that have. I
haven't
physically used it, but I know people that have, and it seems to have worked as well as
this
the
doesn't.
comparable.
At Hamfest, one of my friends asked me, how do you know what the polarization ought to be? I said,
You don't. If you notice when I was doing that, my style, everybody gets their own style doing things.
Yeah.
That's just the way it is. And there's not a right or wrong a lot of times, whatever works for you. But when it's coming up with Horizon, I a lot of times just see me doing like this, just kind of seeing which one's going to bring this on.
If you can optimize it.
Right. As soon as you hear it, I kind of hold that position, get it there, and then I might spin a little more, move it around a little more, just kind of optimize it. And it's important to know the general path it's taking, because if it's going overhead, you don't want to do this number, and so where is it? If it pass overhead, you need to know that so you can pretty accurately follow it. Now, I knew this path was going in this direction, Sober Arc, so I need to kind of generally follow this
I've done the
way.
printout before, just so I know azimuth elevation. I know kind of where it is.
That's what you need to do, get familiar with that.
Okay.
Another way you can do it, if you can accelerate your pass before time, look on your map and just see where it's going, you can do that too, eyeball it. Right. But if you get a general idea with this, it's really great, because you just follow along, and once in a while you'll get interferences too. There's a local interference here due to the ATB that's being demonstrated. The other problems you'll have a lot of times is there's some countries that I know we've gotten interference from, I think, taxi drivers, different utilities that are on the same frequency. And that can be frustrating sometimes. I didn't hear anything today to that effect, but you will get that on occasion. So, but you know, it's always, nothing's perfect. It's always a compromise. But the joy in contacting someone, sending out here with just this equipment and talking to
5
someone
watts. I heard someone from Buffalo. Yeah.
Right. It really strikes a chord with me. I mean, it's incredible. You know, it's a whole different thing. I mean, the system we have over here is an incredible system. It's great.
Yeah.
It's a high-end system, and there's a place for that. But I think there's also a place for doing this, especially when you're demonstrating to maybe kids, which is very important because if we don't get our next generations, you know, interested in this, I don't know where our hobby will go. So that's a kind of a real important chord to me, and I think it's something passionate with me. It's something we need to think about.
Which satellite was this?
This was AO-27. I believe AO-27 was constructed many years ago by AMRAD, and
That's correct.
And they're in, I think
Virginia.
Washington, D.C. is where they're located. They're like a group, I believe, of engineers there that put together the satellite.
Okay.
And it's been a very good performing satellite through the years.
I have tracked it. I haven't been able to do a contact through it yet because the Doppler shift has been confounding me.
Right. Well, this to me was a typical pass that you would hear through there. I mean, just that strong signal.
You had multiple contacts.
Yes. I had 3 solid. I think one was W5IU, wasn't it? I think it was Keith Pugh out in Texas.
Fort Worth.
Fort Worth, and he is an avid MSAT supporter and has many years. He's done wonderful things in schools for kids, demonstrating. He's quite a great hand, quite a good hand.
So with this, you don't need the computer-controlled Doppler shift.
No. No, it's all manual. That's the beauty of it, really. It's all manual.
I did buy the FT897. I mentioned Pittsburgh.
Oh, that's a nice rig.
I haven't looked it up.
Yeah, it's a very nice rig. You'll enjoy that. Now, also, if you're doing contacts with a single sideband mixture like single sideband and FM, there are some satellites that we use to do that. The FT817ND is a good rig, Yaesu rig. It allows you to go ahead. It's not a full duplex rig by any means or crossband that way, but you can get on there. You can get on 440. You can get on 2 meters with it. You can run sideband, multiple modes with it. So that's a great rig to have. And to have this also at the same time, you can hang that rig here and use that rig along with this one. You can do sideband and FM.
This is the one I tried to do it with. Let me ask you another technical question.
Yeah.
At the symposium, they were talking about linear transponders.
Yes.
Explain to me just what that is.
You may have a better handle on those than I do.
My understanding of it was a whole bunch of the band gets transmitted.
Well, it's a whole segment of the band, anywhere from 50 to 100 kilohertz, and anything that's transmitted in that band is retransmitted on a different...
to a corresponding part of a downlink.
Right.
Okay.
Now, whether that is low frequency to low frequency or low frequency to high frequency, they're standard and inverting transponders. If it's an inverting transponder, then the low end of the uplink band is actually at the high end of the downlink band and goes. But
you would know that before you tried to.
Right.
And the rig I have in here as a demonstration rig as a base station, which is on the corner table, is a FT336 or 736R. I'm sorry, Yaesu rig. And it has a setting on there, for instance, for reverse or normal. So you can actually set up 2 frequencies, and as you transverse and reverse, one frequency will go up, one frequency will go down. So it compensates like that.
I do have my call sign.
Yeah.
Did you? Hi. Can I call you back? Let me call you back.
That's pretty good.
That was a good pass. Good job. Does anybody have a problem if we put this on the internet?
Oh, I would love it.
For a demo?
Because I was thinking I was going to record this myself, but you edit.
I mean, that's one thing we wanted to do is to get